Okay, so like I said, you do have this exam coming up this week. And so I'm just going to share my screen. So some important things. This is a review. We'll get into that. So I believe I told you already that you need to have Proctorio installed on Google Chrome. So what is Proctorio? So hopefully you know what Google Chrome is by now. It's a web browser. Hopefully you have this colorful web browser downloaded on your computer already. If you don't, make sure that you download it. And then once you have Google Chrome downloaded on your computer, you need to open up the exam using Google Chrome. So it won't work on Firefox, Safari, or Internet Explorer. So once you're home, go ahead and type in Proctorio Chrome extension. And then click here, install Proctorio Chrome extension, and then you'll just add to Chrome here. So add extension. And then you'll see a shield up here in the upper right-hand corner. Now, once you have that shield there, then you can go about taking the exam. Before you have that shield there, you won't be able to access the exam. So once you have Proctorio installed, you should be able to access the exam. So we're going to be doing this review first. So you can find the exam number 1 review here. This is the review, and then if you want the answers, here's the answer key, so you can check your work to see if you actually did it right. We're just going to do that together today, okay? Before I progress to the review, does anyone have any questions about how I installed Proctorio? Proctorio. And then if you run into a situation where, let's just say you try to access the exam without having Proctorio installed on your, so I'm going to get rid of that extension. I'm just going to remove that extension. So this is what it would look like if you don't have it installed. So you try to access the exam, and you're going to see this, click here to get the extension. And then you just get the extension that way. So even if you don't have it installed right away, you can still get it by just going to the exam, because it won't let you in without the extension. All right, so like I said, download the review, and we can just go ahead and get working on this. So I'll just go ahead and ask you all the questions, and then you all tell me the answers. And then if there's anything that you need for me to elaborate on, just ask me and I'll go more in depth. So let's take a look at this first one. So exam number 1, review. Question number 1, organize an elaborate conceptual scheme that serves to explain how social attributes and events are patterned or related is called a what?
Wouldn't it be theory?
Good. So good. The answer is a theory. Okay. So a theory, a more simplistic way to think about a theory is essentially just an explanation as to how and why things are related the way they are. So like I said, a hypothesis that we discussed in class was something related to social class and health. And so we said that as your social class increases, your health outcomes increase. That's a hypothesis. That's a statement that we made. And that's a statement that we can test. Now, theory explains that dynamic. Okay, so why is it that people from the upper class tend to have better health outcomes, right? And of course, you all had a lot of explanations as to why that's the case. Some people said, well, they have access to healthcare. Some people say that they have a more leisure lifestyle and less stress as a result of worrying about money, right? Maybe access to gymnasiums, and maybe they can afford healthier food. So those are all an explanation as to why social class is related to health outcomes. So that is a theory, it's an explanation, while a hypothesis, of course, as we discussed already, is a statement that you make and then you can test. Okay, so let's go ahead and go to number 2. So question 2, procedures that help organize or describe data collected from a sample or a population are called what?
A.
Correct, so good. Good, Marissa. So the answer is a descriptive statistic. Now, this isn't something that I actually got around to lecturing on live because, you know, week 1 was kind of a short week, but I did lecture on this in the video that I sent you all, okay? So let's just talk about a couple different things. Let's just talk about 2 things, descriptive statistics and inferential statistics, because those are related, but they're different. Can anybody tell me what the difference between a descriptive statistics and what are inferential statistics? What is the difference there? Hint, it kind of sounds like what it is. Okay, well, we already got the definition of descriptive statistic, right? So it's procedures that help organize or describe data collected from a sample or population. So when we think about a descriptive statistic, descriptive statistics, what you're essentially doing is you're describing the data that we get. So I think that's probably the easiest way to think about it is you're describing the data. Okay, so let's just say I wanted to know what the mean age of COD students is. Okay, well, I would add up the age of every single COD student, which would be really, really cumbersome and exhausting, but I could do that. If I had SPSS, I could do it a lot quicker and it wouldn't be cumbersome and exhausting. So what I would do is I would add up every COD student's age and then divide by the total number of students in COD. And I would get the mean age. Then I could describe what the mean age is. Okay, if I wanted to know the percentage of COD students who graduated and transferred to the university, right? I could calculate that, and then I could describe it, and I could put that percentage out for the population to read. Okay, so descriptive statistics, what I'm doing is I'm just calculating any measure that I want to calculate, and then I'm describing the data. Does that make sense to everybody? Okay, so what is inferential statistics? So with inferential statistics, I am inferring, hopefully you all know what the term infer means. What I'm doing is I am inferring from a sample to a population. So if you're using inferential statistics, you need to have a sample. You don't do this with a population, okay? So with descriptive statistics, this can be either for the population or for the sample, because I could describe, you know, information about the whole COD population, because we actually do have all that information, okay? Or I could take a sample of COD students. Let's just say I just take my class, which currently there's 23 participants. I ask you all what your ages are. You all told me that last week. We add all the ages up, divide by the total number of students in the class, and then we would get the mean age or the average age. So I could describe the population if I was looking at the whole COD population, or I could describe the sample. So I'd be doing descriptive statistics for either sample or population. With inferential statistics, what you're doing is you're taking a sample from a population. So let's just say that my population is really big. Just say that, you know, does anybody know how many students go to COD? Or does anybody want to take a guess?
Is it between like 4,000 and 6,000, like 48 to 5,400, or way more?
Oh, way more.
16,000.
Okay, good. Who did you look that up?
No, I just guessed it honestly.
All right. Well, you're almost right on online. You know, basically right online. So the COD population, let's just say this is the COD population, is 16,000 students. Okay. Now, let's just say that I don't have access to all 16,000 students. We do track all that information, but let's just say that I didn't have access to all 16,000 COD students. Well, what I might want to do at that point is I would sample, because I want to know what the average age is of COD students. So what I can do is I can sample. So here I take a small subset from the population, which I'm going to call a sample. And let's just say that you all are my sample. You are the 23 students that I pull from COD population. And I calculate the mean age. Does anybody remember what the mean age was in this class that we calculated last week?
Was it 22? I think I think it was 22 around there.
19. Yeah,
like it was 19. Okay, 19. Cool. So this is a pretty young class then. Okay. So let's just say that this was a sample, and then I use this sample to infer or to make assumptions about what the average age is in the COD population, because I don't have access to the whole COD population. So I say, okay, well, the sample was 19. Well, then in all likelihood, the population mean, this is not the way you write the population mean, but we'll get into that as we progress through the class. Let's just accept this as the population mean for now. But we would say that the population mean is probably going to be somewhere around 19. Now, there's always the issue of sampling error, and we can talk about sampling error as we progress. Let's not go too far. But that's essentially what you're doing with inferential statistics, is you're pulling a sample from the population because the population is too big. You can't reach the whole population. And then you use that sample data that we calculate to make assumptions or to infer about the population based upon that sample data. So obviously, descriptive statistics we're just describing, we can either describe the population if we have that population data, or we can describe the sample. With inferential statistics, we're only dealing with sample data. We are using sample data to infer about the population data. There's no point inferring, if you have population data, you're not going to do inferential statistics. There's no point inferring about something that you already know about. You already have that information, if that makes sense, okay? All right. Okay, number 3. So the levels of social life on which social scientists focus are called what?
Analysis.
Good, units of analysis. So I think that's just a definition that you probably just need to memorize and remember. You know, you could focus on groups, you can focus on organizations. So again, if I wanted to track the transfer and graduation rates of COD students, well, what am I focusing on? COD is a relatively large organization, right? 16,000 students, a lot of workers. So that'd be an organization. So say I wanted to look at unemployment rates in like the United States. Well, then my unit of analysis is countries, nation states. So I can focus on individuals, groups, organizations, nation states. Those would all be what we refer to as units of analysis. That's probably just a definition you need to memorize. Okay, so let's take a look at number 4. So researchers use the term blank to refer to information that is obtained and verified by direct sensory or direct experience.
Empirical data.
Good. So if you'll remember that lecture, I think we were talking about on chapter 1, empirical data, or the idea of empiricism, is this idea that everything that we know needs to be able to be verified with our direct sensory experiences, right? So our touch, taste, smell, hearing, and our vision. And if we can't verify this directly with our sensory experiences, well, then it's just a question of philosophy. So we leave that to the philosophers, to the theologians, to the religious scholars. We only focus on, or we only study empirically things that we can verify with our direct sensory experience. So we don't make moral judgments when we're doing empirical research. We don't make value judgments. You know, is pizza better than tacos? Okay, that's more of a subjective preference that people have. You know, is abortion wrong? That's a moral judgment. We don't do that when we're doing empirical research. Okay, so 5. A blank is a tentative prediction about how empirical events or attributes will be related or patterned.
Would be a hypothesis.
Hypothesis.
Good. So the answer is a hypothesis. Okay, so it's a tentative prediction about how two variables are related to one another. So for example, I think, you know, and I think week 1 we were talking about social class and health. And we were saying that as your social class increases, your health outcomes increase. So your social class would be your independent variable in that context. Your health outcomes will be your dependent variable. And we're saying is as your health increases or your social class increases, your health increases. So that is a prediction. That is a hypothesis that we could then go about testing empirically with data that we collect. Okay. Does anybody have any question about a hypothesis or the definition? Okay. 6, the total set of cases, objects, groups, or events in which the researcher is interested in is called the what?
Would it be variable?
A what?
Would it be variable or?
No.
It's
Population.
Population, good. So if you remember, let's just say I was talking about the mean age of COD students. Okay, so if I'm talking about, I want to know the mean age of COD students, well, then the COD students would be the total group of people that I'm interested in. Okay, so we're talking about the total set of cases, objects, groups, or events in which the researcher is interested in, then that is our population. Now let's just say, like I said, I don't have access to all 16,000 students. So if I didn't have access to all 16,000 students, then I just took a small section of that population. Let's just say I sample 23 students and I don't get the whole 16,000. That wouldn't be the population, that would be the sample. Okay, so a population is a total set of cases, objects, groups, or events in which the researcher is interested in. Okay. And if for whatever reason, which is going to be the case a lot of times when you're doing social research, if you don't have access to the whole population, you then need to pull a sample from that population to then infer about the population based upon that sample data. Okay, so number 7, a subset of cases selected from the total set of cases is referred to, okay, it's pretty obvious right there. What's the answer to this?
Sample.
Sample, right? We just talked about it. Okay, good. Any questions about that? Okay, so let's talk about what is the formula for a proportion?
It's A or C.
It's
I think
A.
it's A.
A.
It's A. I don't know why I thought 100 was in that.
Okay, there's a reason why you might think that 100's in there, but so the
Getting it mixed up.
formula for proportion is P is equal to the F divided by the N. So the proportion is equal to the frequency of a category divided by the N, which is, what is the N again?
Total number of cases or variables.
Right, so the total number of cases in the distribution, good. Now, the reason why you might be thinking C is the answer is because C is the equation for something different. What is C the equation for?
the percentage.
Percentage, that's what it was.
Good, percentage. Okay, so obviously when you have a proportion and you want to convert that to a percentage, what you do, you take the proportion, you multiply by 100, and then you get the percentage. And obviously when you're reporting, you know, relative frequencies is what they're called, you'd prefer to report percentages as opposed to proportions, because proportions have decimals. And I'm telling you, if you start throwing proportions and decimals or fractions at people, people get scared and then they get intimidated by that. So it's best that whenever you have a relative frequency, say you have a proportion, just go ahead and turn it into a percentage. They're pretty much the same thing. And it's easier for people to read and understand. Did you have a question, Tyler?
No, I didn't.
Okay, good. Does anybody have any questions about that? So you might have to, on the exam, convert a proportion to a percentage and back and forth. So just make sure that you are aware and that you know how to do that. Okay, so let's look at number 9. So relative frequency obtained by dividing the frequency in each category by the total number of cases and multiplying by 100 is a what?
Percentage.
Right, that's another one that's obvious. Okay, so this one, let's take a look at number 10, 11, and 12. And then we need to go about calculating the mean, the median, and the mode. So for 10, it's asking for the mean first. Okay. So I'm going to need you all to actually do this calculation for me because it's actually kind of like a long, tedious process. So what am I going to do here? How would I go about calculating the mean here?
Wouldn't you add all the numbers and divide by how many numbers there are?
Good. So how many numbers do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so we have 19 altogether. So what we need to do is add all these numbers up and then divide by 19. So why don't you all go ahead and add these numbers up, and then I'll start working on it as well. Because we need to make sure that we get all of them together. Because it's easy, you know, when you have so many numbers to make a mistake, and if you make one small mistake, it throws everything off.
I got 43.
You got 43, okay. Let's just go ahead and keep on going, and then like, let's see, make sure that we get the right answer. Yeah, so I think it added up to 817, unless it's easy to make one little mistake, and one little mistake throws it off. So I'm going to take this, I'm going to divide by 19. We're going to get, so the answer is 43. Did everybody see how we did that? Okay, so the answer for the 10 is 43. Now we need to go about finding the median. Actually, let's find the mode first, because that's going to be pretty easy. So for number 12, what's the mode?
74, I think.
And 18.
Yes, I think that there's actually two modes, because I see a 74 here and a 74 here. So there's two of those. So that's the mode for that. I think there's two 18s. There's an 18 here. Is there a second 18? Oh, okay, so 18 here and an 18 here. So there's two 18s. So we call this what type of distribution?
Binomial.
That's close. It is
Bimodal.
good. So,
Bimodal.
good. It was pretty close. But so it is a bimodal distribution. Binomial is something that you would learn if you take more advanced stats classes. But good. All right. So now that we know that we have the mode is 18 to 74, we have a bimodal distribution. Let's go ahead and like solve number 11. So how do we go about solving number 11? How do we go about finding the median? Can somebody remind me of how to do that?
You add
Oh,
plus
sorry.
1 divided by 2.
Okay, so the first, well, before we get to that point, but that is one of the processes, one of the things that we have to do in the process. The first thing that we need to do is line the scores up from lowest to high. Okay, so let's go ahead and do that first. Let's line them up from lowest to high. And then what we do is we take the n, which we already know that the n is 1, or n is 19, we add 1 to it, and then we divide that by 2. 19 plus 1, doesn't take a rocket scientist, that gives us 20. We divide that by 2 and we get 10. So what we need to do is first off line up the numbers from lowest to high. And why don't you all go ahead and do that, and then I'm going to try to see if I can do it up here on the whiteboard by myself as well. Actually, can you all tell me the numbers if you all think you can put it up in order? So I know the 5 is the lowest.
It goes 5, then 7, then 8. Then it looks like 14. From there it'd be 18. Two 18s.
5, 7, 8, 14.
5, 7, 8, 14.
Okay, and two 18s.
Two 18s. And then we have no 19s. We have that looks like 22. 22 would be next.
Okay.
27 and 29 and 30. 37. No 40s. 52, then 55. And then I think it would be 67. 67 should be next. And then I think the 274s. And then I think 89. Yeah. That's all of it.
There's also a 92 in there.
Oh, got that. My bad.
All right, thank you. So I think we got all 19 of them. Okay, so now that we have all 19 up here on the board, they're lined up from lowest to high.
What is the 99 too?
Oh, we have a 99 there too?
Yes.
Oh, didn't catch either of those.
Like I said, it's easy to make a mistake. So when you're doing this, make sure that you get all the numbers.
Yeah.
And so if we know that they're 19, you could easily just count it over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
18,
And if you have all 19, then you know that you're good to go. If you have like 18 or 17, or if you have 20, then you put too many. Okay, so we have them lined up from lowest to high. We got our n, which was 19. We added 1 to it. We got 20. We divide that by 2, and then we have 10. So what we need to do is then count over to the 10th number. And then that 10th number is our median, which divides the distribution perfectly in half. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 30 is our median. 30 is our median here. So one way we can check it is we can count it over. 1, 2, 3, 4, 5, 6, 7, 8, 9 scores are below this point. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 scores are above this point. So this is the point that divides the distribution perfectly in half, where half the distribution is above and then half of the distribution is below that point. Anybody have any questions about how to go about solving that?
So when it's an odd number set, you're gonna always have the number in the middle. But when it's an even number set, don't you add the 2 and divide it by 2?
Yeah, good. So I might as well go ahead and like show that then. So because you might have to do this. So let's just say that we add another number to it. So let's just say that we just so happen to have had 100. So in this situation, instead of having 19, we have 20. Our n is 20. So we add 1 to 20 and we get 21. So we divide 21 by 2 and we get 10.5. Okay. So we do the same thing. We count over to 10. So we go 9, 10, and then we have, this is 11. So we need to find the number in between these two numbers. So the exact middle in between 30 and 37. In between 30 and 37. So the way you would do that is you would take 30 and 37, you would add them together and divide by 2. And then that's how you get the exact middle between those two numbers. So we did 30 plus 37
0.5
equals 67. We divide that by 2, and then we're going to get what? I think somebody said it already.
33.5.
Good, Lauren. So we got 33.5. So 33.5 is the exact middle between these two numbers, and then that is our median. So now we have 10 scores below and then 10 scores above. Anybody have any questions about that? Good. Thanks for pointing that out to me, Tyler.
You got it.
Anybody have any questions about how to do that? Okay. So now that we got 10, 11, and 12, let's go to 13. So about 13% of survey respondents in a sample reported that they do not attend religious services. About what proportion of respondents did not attend religious services regularly?
0.13.
Good, 0.13. Everybody see how we got that? Okay, if there's no question about that, then we can just move along. Just be aware of some of the problems you might have to figure things out mathematically like this, but you also have things that are conceptual. So you need to understand that I have a percentage, I need to get it to a proportion, divide by 100. Okay, so the sum of all frequencies in a frequency distribution should sum up to what?
100.
No.
N.
1.
N. Okay, so N. Now, if y'all remember, there was kind of like 3 things that we talked about in chapter 2, right? There was the frequencies, there is the proportion, then there's the percentages, okay? So the frequencies in a frequency distribution need to add up to the n, which is the total number of cases. So for example, let's just say that I was talking about sex. So let's just keep it simple. Let's just say I wanted to create a frequency distribution for the variable sex because I wanted to know how many males and how many females are in the class. Okay. So the variable is sex. This is the frequency. Let's just say that this is the proportion and then this is the percentage. Okay. So we have, let's say, two categories to make it simple. We have females. We have males. So what we would do is let's just say that there's 10 females and then there are 5 males in the class, okay? So the frequencies need to add up to the n, which is the total number of cases in the distribution. So the 10 plus the 5 needs to equal to 15. That's the total number of cases. Now the proportions, the way you'd go about getting the proportions, I think we already talked about this, is you would take the F for a particular category and divide it by the total number of cases. So if you do 10 divided by 15, you're going to get 0.67. So let's just round it. 0.67, so that's 10 divided by 15. Now, some people already said this, the proportions need to equal, what do the proportions need to add up to?
100.
What do the proportions need to add up to?
1.
1.0. So if this is 0.67, I don't really need to do the calculation for 5 divided by 15. It's not going to take that long, but I don't necessarily need to do that. Because if this is 0.67, what do I need to have here to get to 1.0?
33.
0.33, good. So I could just put 0.33 because I know 0.67 plus 0.33 adds up to 1.0. If you can't just visualize it in your mind, you could take 0.67 and subtract it into 1.0 and you'd get 0.33. Okay. Now, obviously for the percentages, I know that you multiply by 100, you're going to get 67% here. Same thing, multiply by 100, you're going to get 33%. And then the percentages all need to add up to 100%. So just be aware of this. The frequencies add up to the n, proportions add up to 1.0, percentages add up to 100%. So when I ask the sum of all frequencies, sum up to the n. All right, so imagine one of your colleagues is constructing a pie chart to graph results of data collected on respondents' occupational prestige score. A score which can take on any non-zero value. What should be your first response upon reviewing the work?
A or C, but I think it's A. Can I change
Okay, good. So the answer is A. Now, it could be C.
Yeah.
In the sense that you could have frequencies in a pie chart, but that would be a bad way to construct a pie chart because, you know, like I said, the numbers could be really, really big and when you're looking at frequencies. So you might have a pie and you might only have like a little slice of the pie, but there might be 1,500 respondents in that little slice of the pie, which then if you have the frequencies might completely overwhelm that little slice. So it's best to use percentages. Okay, so the answer is A, to note whether the slices of the pie sum up to 100%. Now, you can look at some of the other responses. B, to suggest that your colleague had used an inappropriate graphic device. If you have nominal and ordinal level data, which we're looking at respondents' occupational prestige score, that's actually ordinal level data, then a pie chart or a bar graph is actually appropriate graphic device. So that's not the answer. C, to ensure that the frequencies add up to the n, is not the correct answer because, as I stated already, you typically don't want to put frequencies into a pie. And then D, to check whether the bars representing the categories were contiguous as they should be. Again, we don't even have a bar graph, so that one doesn't even make sense. So that's certainly not the answer as well. So the answer would be A. Now, like I said, you might have some questions like this. Like I said, you know, it's not just one thing to know what a pie chart and a bar graph looks like. You also need to understand how the level of measurement connects to this type of graphic device, interval ratio level data, what graphic device does that connect to? If you have nominal or ordinal level data, which type of graphic device can you use with that type of data? Okay, so 16. Which of the following statements is true about time series charts?
Would it be
No.
A? No.
C.
No, say again.
No, the answer is C. Okay,
Is it C?
so A, time usually measured in months or years is placed on the vertical axis. 1, time is placed on the horizontal axis, so that's the first thing. And then 2, there's no reason why the time needs to be measured in months or years. I mean, let's just say that you want to track your weight. Like this is you're trying to lose weight. You can create a time series chart of your weight. So your weight would be the variable of interest, and then that would be on the vertical axis. So you could look at, maybe we're looking at, how much you weigh. So let's just say 100. I'm just gonna try to keep the number simple. 95, and then 90. And then let's just say that we say that this is day 1. So we could just do it by day. This will be day 2, this will be day 3, 4, 5. So you can do it by day, and then this would be kind of like time, and it's on the horizontal axis. And let's just say day 1, you're 100. And then day 2 is to say you're around 97. And day 3, you're 95. For whatever reason, you're anorexic because you're already really, weigh very much, and you're trying to lose even more weight. But so that's what a time series chart's time is on the horizontal axis. And then the variable of interest, usually you're going to have this as frequencies or percentages, is going to be on the vertical axis. So horizontal x-axis, vertical y-axis. Anybody have any questions about that? Okay, and then you can look at some of those other responses and just kind of like see that they're not right in the sense of the heights of the bars proportional to the frequency or percentage of the observations. You're not really looking at a bar per se. You're more usually create it with a line. And then D, the changes in the variable must always increase over time. Like I said, with your weight, if you're looking at your weight doesn't necessarily always increase over time. It could decrease. 17, so in a blank, the bars which represent categories of a variable are spaced so that one bar is not directly next to another, whereas in another blank, the bars actually touch one another.
A?
A, good. So in a bar graph, the bars which represent the categories of a variable are spaced so that one bar does not directly touch another. Because if you, let's just say you're dealing with nominal or ordinal level data, there's no reason for the bars to touch, because you would use a bar graph if you have nominal or ordinal level data. There's no reason for the bars to touch because the categories are typically separate. Let's just say we're talking about religious affiliations. To say we have one category, we have a little bar graph, we have one category. More religions than what I'm about to throw out right now, but I'm just going to keep it simple. Buddhist, and then we have Christian, we have Islam, and then we have, let's just say, percentages here. And we have 10%, 20%. Say we have Buddhists here. Let's just say 20% of the group is Buddhist. 40% is Christian, and then another 40% is Muslim. So there's no reason for these bars to touch because they're separate categories and separate distinct categories. So that's a bar graph. But if we have an interval ratio level variable and we're creating a histogram with interval ratio level data, let's just say we're looking at the variable age. Then let's just say we have 18 here. Let's just say there's a bar here. Well, then the next category would be 19, and there'd be a bar that's touching it to show that there's a logical continuation from 18 to 19. Then we have 20, and then we'll say there's 20-year-old, and 21, and then so on and so forth. So that's the difference between a bar graph and a histogram. Bar graph, the bars do not touch. Histogram, the bars do touch, and there's a logical continuation from one bar or one category to the next.
I had a question.
Yeah.
Are histograms typically going to always be numbers?
Yeah. So
Yeah.
if you're dealing with interval ratio level data, you need numbers.
Sure. Okay.
Yeah. Okay, so. Okay, so 18. Which of the following graphic devices is not appropriate for interval ratio level data?
Frequency Polygon. I think we.
Pie chart.
Pie chart, good. So why? Because as we discussed already, with interval ratio level data, you can have a lot of categories. We're looking at the variable age. Variable age in the general social survey, the categories range from 18 to 89. So 71 categories. Could you imagine looking at a pie chart with 71 different slices? Almost impossible to read. So because of that, you wouldn't want to use interval ratio level data with a pie chart. Histogram, frequency polygon, time series chart, those all work. Okay, so let's take a look at 19. So this is probably some of the more complex stuff. So let's go ahead and let's find the mode for, let's just do it for both males and females. Hopefully everybody kind of understands what we're looking at here. So this is the US Bureau of Justice reporting the estimated percentage of sentenced prisoners under state and federal jurisdiction by sex and age as of December 31st, 2014. Percentages are represented in the following table. So what categories for males and females are the mode?
30, 34.
30 to 34, good. And then for females, what category is the mode?
The same.
Good, 30 to 34. Now, hopefully people are also understanding that what you're looking at. So we're calculating the mean, median, and mode again, right? Or no, not the mean, but so we're calculating the mode and the median. Now, we did this earlier, but it looks way different, right? So this is again a list of scores. Hopefully everybody realize that, the list of raw scores. And then here what we're looking at is what is this called again? This is a frequency.
I was going to guess frequency table or frequency graph.
Frequency table, frequency distribution. Okay, so we're looking at your frequency distribution. So there's ways to find the mean, the median, and mode in a list of raw scores, and there's a way to find the mean, median, and mode in a frequency distribution as well. But we're not finding the mean here because we don't have interval ratio level data. Like I said, when ages are grouped together like this, it's no longer interval ratio, it's ordinal. So we can find the mode and the median. The mode was simple, just look for the biggest number. Now, if we were to find the median, what would we do here? How do we find, let's just say we're trying to find the median for females. So for first, let's do it for females and then we can do it for males. We're trying to find the median for females. What would we do here?
We have to create a cumulative distribution.
Right, so we need to create a cumulative percentage distribution. That's good. Now, I might as well just draw it up here on this board because I don't know if I'm going to be able to. Actually, I'll do it here first. Nah, I'm just going to draw it up here on this board. It's going to be simpler if I do it on the board. Okay, so what we're going to be doing is, so we have females. We're just going to look at females first. And we have the 18 to 19 category. And then for the first category, the frequency or the percentage is 0.6. Percentage is 0.6. So then what I do after that is I create the cumulative percentage. 18 and 19. We're running out of room a little bit, but I think I probably will need to go to 50 to 54 anyways. Okay, so what we would do here is we create the percentage first, and then we create the cumulative percentage. So we know that there's 0.6 here, there's 10.0 here, 8.6. Okay, so let's just say this is all we were able to get to. So for the cumulative percentage, what we're going to do first is we're going to take the percentage in the first category, then we're going to move it over to the cumulative percentage because we're going to add the percentages to the next category. So we're going to go 0.6 here. What are we going to do with this 0.6 now?
Add it to the 10.
Good, so we're going to take, yeah, so we're going to add it to the 10.
Add to the next one, 10.0.
Right, so we're going to add that and we're going to get 10.6, right?
6.
Okay, well, what do we do with this 10.6?
Add it to 70.5.
We're going to add it to the next category. And when we do that, we're going to get like 28.1 or something like that.
28.1.
28.1. So we take this 28.1 and then we're going to add it to
18.6.
18.6, right? And then when we add that 18.6, we get 46.7, is it?
Yes.
Okay, and then we take this 46.7, we add it to this 14.7, and then we're going to get what?
61.4.
Now I can kind of stop here because I'm basically just running out of room. So now that I've created this cumulative percentage, I've gotten to 50%. Now I need to see where that 50% mark is because that's where the median's at. Okay, so now that I have that, let's say I'm looking for 50%. This isn't 50%, that doesn't make sense. This isn't 50%. This isn't 50%. Where is 50%? 50% is right around here. Everybody see that? 50% somewhere going to be somewhere around here. Now, what a lot of people do is they make the mistake. They say, okay, well, this is 46.7, so this is closer to 50%. So I'm going to go with this category, but that's not the right way to do it. Okay. So what you're going to want to do is you want to go to this category. So the way you go about thinking about this, or at least the way I like to think about it, is I go in this category. Before we get to this category, we have 0 observations in the distribution. So we have 0% of the distribution until we get to this category. And now we have this line represents 0.6. We add this category, and now we have 10.6. So this line is 10.6. We add this, and we get 28.1. This line represents 28.1. We add the 18.6. This line represents 46.7. And then we add 14.7, and this line represents 61.4. So now that I have 46.7 is this line, 61.4 is this line, I can kind of even erase this like cumulative percentage distribution here. And I just know that here, 50% is going to be above this number. It's going to be below this number. So it's going to fit right in here to this 35 to 39 category. Does that make sense?
So yeah, for the category, it's going to always have to be, it's going to be in the category that's always higher than the percentage, right? It's never going to be the one that's below.
Yeah, so that's the other way that students have told me that they thought about it, is that you look, 50% is between 46.7 and 61.4, and then you could just take the lower one. So that's the other way you could think about it. but then you might not understand why are we taking the lower one. So I try to
Yeah.
explain 0, 0.6, 0.6, and 0.6. Like
Yeah.
the lines represent those different.
That's better because the other way is kind of generic and it could change.
Yeah, so I don't teach it that way, but some students just, they look, okay, this is 46.7, this is 61.4, 50% in between these two, and I just go to the lower one. But then you don't really understand why you're going to the lower one. And then again, don't go to the closer one, think about this line is 46.7, this line is 61.4, 50% is going to be right there. Now you can do this technically with any percentage at this point, right? So you can find the 25% mark, you can find the 75% mark. So you can find percentiles, you can find the 20% mark. I didn't find the 75% mark because like I'm just running out of space here, so I just stopped. And since we're only trying to find the median, that's essentially all you really need to do. Okay. Everybody understand how that works?
I was going to ask if it was to be 25, it would be the 28.1 probably, right?
Yeah,
In
so
that
this one's
category?
so this one's 10.6 to 28.1. So go 25 to 29.
All right, cool.
Yeah.
Just want to make sure I know how to read it.
Okay. Anybody else have any questions about that? Okay, so if you all don't have any questions, somebody tell me what is the median for males? What is the median for males?
35 through 39.
Same? Okay, good. Like I said, you do the exact same process. You would create a cumulative percentage distribution, find where that 50% mark is. If you can't figure out where the 50% mark is, take these numbers and then take the line and take the number down to the line. And then find where that 50% mark is in between. Okay, good. Now let's go ahead and do C. What proportion of the distribution is 45 and older? Let's just do it for females. Let's do it for females.
Would be 60.
45 and older.
Would it be 85?
No, but what proportion? Or
60%.
okay, so when I say that what proportion is older than 45, so what we're going to do is we're going to look, okay, so 10.9% is 45 to 49, right? 7.7 is 50 to 54. 3.9 is 55 to 59. 1.8 is 60 to 64, and the 1.2 is 65 and older, right? So what I would do is if I'm trying to find 45 and older, is I would take these percentages here, and then add them up, because that's everybody who's 45 and older. Does that make sense? So I just add those together, and then I would get 25.5%, which if I'm converting that to a proportion, I'm just going to divide by 100. It's going to be 0.255. Does that make sense, everybody?
Yeah.
So I didn't really know where people were going with the 60% and stuff like that. Yeah, so you would just add these categories or these percentages together.
Yeah, I would say so if it was just for generic 45 or older, you do the same thing for the other category and just add it all up, right?
Yeah.
Okay.
All right, so I think the last one is, okay, so what we're going to do here, let's get extends into the next one. What we're going to do is we're going to try to find, considering the information in table 1, do a higher percentage of Blacks have 5 or more children? Okay, so that's the question. So how are you going to go about solving this one?
You would do the same thing in letter C in the previous problem for this one, correct?
Similar, you do, but you're looking at frequencies this time, right? So what you'd first have to do is you would have to find the n. to then find the proportion to then find the percentage, right? So if we're looking at do a higher percentage of whites or blacks have 5 or more children, we'd have to find what that percentage is first. Everybody still with me? Okay, so the first thing that we'd have to do is we'd have to find out, well, how many blacks or African Americans are in this sample? So what we'd have to do, I'll pull this calculator out. So I know that for 0, there's 151 plus 126 plus 13, I messed that up, 36 plus 105 plus 45 plus 25, 10 plus 13. So my N here is 630 African Americans, correct? So that is my N. And then what I need to do is look at how many out of that 630 has 5 or more children. Well, how many have 5? 25, okay? Plus that 18 gives me 43. Plus that 13 gives me 56. Plus that 11 gives me 67. Everybody still with me? Okay, well, what do I do with that 67 and this 630? Good, I divide. So I would take 67 divided by 30. So 67, I'm going to divide that by 630. And I'm going to get approximately like 11% of, or at 0.106, which is kind of like, if you round up, it's going to be about 0.11 proportion. Multiplied by 100, we're going to get about 11% of blacks have 5 or more children, okay? Now I have to do the exact same thing for whites in the sense that I need to find the N first. So obviously there are substantially more whites in the sample than blacks. So, you know, even though, so what we do here, we'd have to find the N first. So we found the N for African Americans, we need to find N for white. So we go 903 plus 513, right? Plus 872 plus 531 plus. Okay, so the N, like I said, is substantially larger, 3,276. Now what I need to do is find out how many whites have 5 or more children. So there's 83. So 3,276, we just need to hold on to that number for now. 3,276 is our N. We need to do 83 plus
134.
Is that right? 83 plus 51 plus 25 plus 16. It's actually 175. Then we're going to divide that by 2,276. And we're going to get 0.05, which is essentially, if you multiply by 100, is going to give you something around
5.34.
0.34.
about 5%, right? So we're just going to go ahead and round that down to 5%. So we can see that, yes, there is a higher percentage of African Americans have 5 or more children than whites. So that's how you go about calculating that. Anybody have any questions about anything that we've discussed so far in this review?
Quick question on 20. So even though the N's are like substantially different, is that like in its own way a form of outlier, or that it just doesn't matter? It just happens that the N for the whites was like way more than the blacks?
It just so happens in the United States, there's just a lot more white people than black people. That's
Okay.
just the way the data. So it's not necessarily the N or the frequency that you need to focus on so much as you need to focus on the percentages. And that's what's more relevant. Okay, good question now.
Oh, I have one more question.
Yeah.
A second. For like a question like number 20 on the test, is it going to be like a multiple choice thing, or are we going to have to input the answer?
It's going to be a multiple choice. So you'd have an option of like 4 possible responses.
I was going to say, if we have a test in the future where we have to input the answer, would you want it to the 10th place, 100th place, like for decimal like that?
Typically it's 100th, but 2 decimal places. So, and then a third number determines whether or not you round up or down. But for the exams, it's almost always going to be, it actually is all true, false, multiple choice.
That's good.
So, but before we move on? Are there, so this was all, so, okay, so let's go ahead and do this, because this is something that you also might run into. How do you calculate the mean here in the frequency distribution for question 15? How do you calculate the mean?
You have to add like all the frequencies.
And then
with-
divide by 7, right?
No, so the first thing is we add up all the frequencies together to get the n. So we're gonna throw that calculator out again, and we're gonna do, so the first category is 5 plus 12 plus 8 plus 3 plus 1 gives me a 17, 25, 28, 29. Gives me an n, which is 29. Okay, so that's the first thing that we need to do. Everybody's with me? Our n is 29. Now what we need to do is, if you all remember that formula that we had for the mean and the frequency distribution, can anybody remind me what the formula is for the mean and the frequency distribution?
It's the mean equals raw scores times the frequency. Oh, where, yeah, a score multiplied by its frequency over n divided by n.
Okay, good. So hopefully you all remember this. So the way that this is different than what you would typically do is typically you would just add up all the raw scores and then divide by the n. But when you have a frequency distribution, you need to multiply the raw score by its frequency. So since we're looking at a frequency distribution here, what we need to do is we need to take each raw score and multiply it by its frequency. So if we have one child, you don't just take 1, 2, 3, 4, 5, 6, 7 and add them up and divide by 29. What you do is you take this one child. How many people have one child?
5. Oh, so it's 5.
So it's 1 times 5. So 1 times 5 gives you 5, right? Then we're going to add that to 2 times 12. What is 2 times 12?
24.
So you cross multiply the table.
Yes, yes.
That
And
makes
then
sense.
3 times 8, again, it's going to be 24.
4 and 12 and 1.
Then 12 here.
Plus
Then 0, 0, and then we have 7.
2.
Everybody with me? Now what do I do? Now, so what I've done is I multiplied the raw score by its frequency. Now I need to, and I added them all up, obviously. They added up to 72. I divide by the 29. And I'm going to get about 2.48 is the mean number of children for this data. So that's how you calculate the mean in a frequency distribution, okay? Which is something you might have to do in the exam. Obviously for this one, yeah, go ahead.
Sorry, but what you did, when you divide again, I just wanted to add that real quick to my notes.
Divided it by 29. So after we added all these the frequencies all together, 5, 17, 25, 28, 29, that's our n is 29.
Okay.
That's how many people were in the sample. Now this one, like I said, this is pretty similar, to what we did on question 19 for the median. What you do is you create a cumulative frequency distribution. So you do 120 plus 181, 301 plus 264, 565, plus 517, 1082, plus 257, 1339. So you create that cumulative frequency distribution. And then you can either convert those to percentages, or what you could do is obviously, just take the 1339 and then multiply by 0.50, which is essentially the equivalent of like 50% mark, right? The exact median. And then find where that 669.5 is in the cumulative frequency distribution. Or you could just take all these frequencies and then convert them to a percentage and create a cumulative percentage distribution, and then find where that 50% mark is. Okay. Anybody have any questions before, we get out of here?
I think it was the last question on here where it was like the 70, the 25th percentile. I was having trouble with that one.
Okay, good. So like I said, if you were running into an issue, this is somewhat similar to what you see up here, but the percentages have already been calculated and the cumulative percentages have already been calculated for you. So what you would do here is, so this one's asking 50th percentile is the median. Right. So you would you create the cumulative percentage distribution, but it's been created for you. So you can skip that. So like I said, what you would do is you would take each number is kind of like that line. So this number 34.4 is this line right here. This number is this line, 78.1. So if we're looking for that 50% mark, it's going to be
40 hours.
Yeah, and then you do that for any other percentage. Well, if we're looking for the 25% mark, well, this line, 21.9 is this line. This 31.3 is this line. So that 25% mark is going to be where?
30 hours.
30 hours.
30. And then if I think what did it ask for 75% as well? So
I got 75 wrong. What did I put? So do you go to the 75% area? Like this?
yeah, but it's going to be right here too. See, 34.4, 78.1.
Okay. I think I put 40. I don't know. I got it wrong. So yeah, I was trying to
So
figure.
when it's asking for percentile, you look at the cumulative percentage and you do what we always do with the lines.
Yeah. So it's asking for the cumulative percentage, or you create the cumulative percentage or the cumulative frequency distribution, and then do what I did with those lines. Just this line right here. That line is this line 34.4. This line is 78.1. If I'm looking for 50%, I know it's going to be in here. If I'm looking for 75%, I know it's going to be between these two lines.
And when it's asking like the level of measurement, is it like interval ratio or?
Yeah, so actually, hold on, so if we're looking at the level of measurement, so we're looking at this as interval ratio. So if it's looking at hours worked last week, you can see that this is 20 and this is 25, right? So we have at least order here. So we know it's at least ordinal. But 25 and 25 is 5 more than 20. 28 is 3 more than 25. 29 is 1 more than 28. So we can actually measure the distance between the categories as well. And when we can measure the distance, we have interval ratio level data. So here we know that this is interval ratio level data. The mode, it's easy to find. I mean, just the biggest number, right? Nothing really to talk about there.
40.
Anything else? All right, so I'm gonna stop recording this. So
actually, could you go over question 18?
okay, let me share my screen again then. Question 18 as far as this one, or what we had on the review.
On the homework.
Okay, so all you're really doing here is you're looking at the, I'm gonna stop recording because we don't need this for the review.